In this video, we're going to talk about the layers of Earth's atmosphere. So Earth has 5 different major atmospheric layers. Those can be combined further into the lower layers and the upper layers. Let's go and take a look at the lower layers first. So the first of the lower layers is the troposphere. The troposphere is where you live, eat, sleep, and play. All life, or all complex life, lives in the troposphere. It also contains most of Earth's water vapor and most of Earth's gases as well. All weather and clouds usually occur in the troposphere as well. Now, there are some instances where some clouds can make it into the stratosphere, especially if there's a volcanic eruption, but for the most part, weather occurs in the troposphere. Now, in the troposphere, and in all layers, the pressure drops as altitude increases. And the reason for this is there are less air molecules in order to exert a pressure nearby. So at the top of the troposphere, there's only 1/5 of the sea level pressure, which is not enough to breathe at as well. Now, temperature also drops as you go higher in the troposphere, and this should kind of make sense. As you go higher in the mountains are colder than the valleys. So for every 1,000 feet that are climbed, temperature drops about 3.6 degrees Fahrenheit or about 1 Celsius. Now this stops once you make it to the stratosphere. So in the stratosphere, about 10 kilometers high or about 6 miles high, and it goes up to about 50 kilometers to about 30 miles high. Temperature increases with altitude. So instead of temperature dropping as you go higher, in the stratosphere, temperature will actually increase. Now, it doesn't help very much because the stratosphere still, on average, is the second coldest layer on the Earth. It is heated by some radiation from the sun, but for the most part, it's pretty cold. Now, the stratosphere, notable things about it, it contains the ozone layer. It also contains the jet streams. And it contains very little air. Now, the stratosphere itself contains about 24% of Earth's air by mass. It includes the ozone layer as well, as you can see there. But for the most part, the stratosphere is very, very thin. So you would definitely not be able to survive in the stratosphere. Now, there is no weather in the stratosphere unless you consider the jet streams, so the air is very calm. So that is one reason that some commercial aircraft will actually fly in the stratosphere in order to take advantage of the calm weather as well. Now, if you've heard about convection currents and how that influences Earth's weather, convection currents don't usually occur in the stratosphere. The only thing that has moving air in the stratosphere is usually the jet stream, and that's going to be at the bottom of the stratosphere only. Now, more air hangs out near the ground. You may have heard me of saying that, and the reason for that is pressure. So think of the air or the Earth's air like a marshmallow. And the more you squeeze a marshmallow, the more pressure you put on it, the smaller it gets and the more it crushes down. And Earth's atmosphere is a lot like that. So Earth's atmosphere is squeezed close to Earth's surface, or its sea level surface, because there's a whole bunch of air molecules above it pushing down on the sea level air. And as you go higher up, there's less air above it pushing it down, so less pressure. If we move to the upper layers, which includes the mesosphere, the thermosphere, and the exosphere, let's go ahead and take a look at those. They only contain about 1% of Earth's atmosphere by mass. Now, by volume, they make up about 90% of Earth's atmosphere by volume. You can see the thermosphere especially looks incredibly large compared to the other layers. Let's take a look at the mesosphere first. So the mesothe is between 55 kilometers and 80 kilometers in altitude. Now, it is the coldest layer on Earth. Whereas the stratosphere was the second coldest at negative 55 Celsius, the mesosphere average is negative 101 Celsius, which is colder than dry ice, but warmer than liquid nitrogen. Now, the mesosphere is the layer in which meteors burn up, and you really can't get there with aircraft. You really can only get to the mesosphere using rockets. And even if you were to get there in something like, say, a space shuttle, you can't stay in the mesosphere because there is enough air to actually slow down spacecraft and bring them back down to Earth. So it's really hard to measure the mesosphere because without, sounding rockets or something, measuring or scientific devices don't stay up there very long. Now, more about the mesosphere. I mentioned meteors burn up in this layer. And in fact, there are some clouds called noctilucent clouds that are actually from meteors burning up in this layer. Now, they're only visible in the early morning or the late night, right before or right after the sun sets. And so they're not actual water vapor clouds in the fact that they come from the Earth's water cycle. They actually come from meteors and comets and things. Now, the thermosphere is above the mesosphere. The thermosphere is where you would think of as space. It is basically space. The International Space Station is in the thermosphere. A lot of rockets and some satellites are in the thermosphere as well. It is the thickest layer, and it is so thin that even sound would not be able to travel in the thermosphere. So, for all intents and purposes, it is the beginning of space. Now, auroras happen in the thermosphere, as well as, satellites and some spacecraft. A little bit more about the thermosphere. The name thermo means heat, and this is one of the hottest layers on Earth. Now, when I say the hottest layers on Earth, if you were there, you would actually feel very cold in the thermosphere. In fact, assuming you had a spacesuit on, it would still feel very cold, almost colder than freezing. So what's going on there? Well, even though the average temperature of the air molecules in the thermosphere is above 2500 Celsius, there's just so few air molecules that it would feel quite cold in the thermosphere layer. They just don't run into you very often. Now, going even beyond the thermosphere, we have the exosphere. So the exosphere is anything beyond 800 kilometers. So anything from the thermosphere 600 up to 800 kilometers is the exosphere. And there are satellites in this layer as well, medium Earth orbit satellites, geostationary satellites. But it's just so thin in this layer that this is definitely considered space as well. And so in this image at the bottom here, everything in the dark blue is considered the thermosphere. So you can see the thermosphere definitely takes up layers of the Earth, but it is also right next to space. So it's very, very thin. Now, we've talked about Earth, but what about the other layers of the Earth that you may have heard of, like the ozone layer and the ionosphere? Well, the ionosphere is a layer of electrically charged particles. It's mostly made up in the mesosphere. So if you want to know where the ionosphere is, it's within the other layers of the Earth. Now, what can the ionosphere do? It can bounce around radio waves, usually AM radio waves, and it can send them traveling a lot farther than they could possibly travel on their own. Because ionosphere or AM radio, the ionosphere can actually bounce them off and send them back to the Earth much farther away. Now, what about the ozone layer? The ozone layer, as I mentioned earlier, is mostly within the stratosphere on Earth. So it's somewhere between about 19 to 48 kilometers above us. It's made of ozone, which is O3. And the ozone layer is just one constituent. So ozone, O3, is not the only gas in the ozone layer. There's still nitrogen, there's still regular oxygen, there's still other gases as well. It's just the ozone layer also contains a lot of ozone. Now, what about other planets? Venus and Mars. They have atmospheres, so do Jupiter, Saturn, Uranus, Neptune. Even Pluto has an atmosphere. So let's take a look at our two closest neighbors, Venus and Mars. So Venus has an atmosphere about 90 times thicker than Earth's. It also contains mostly carbon dioxide, carbon monoxide, and sulfur dioxide, and some nitrogen. Mars's atmosphere is about 1% of the Earth, so you can almost say it's 90 times thinner than Earth's atmosphere. And it also contains mostly carbon dioxide, nitrogen, argon, and some other elements as well. So why is the pressure so different on these two planets? Well, Venus has so many more atmospheric molecules, it has so much more atoms that it just can't help but exert more pressure. And Mars has so few atoms that there's so little pressure on Mars. Obviously, the gas giants like Jupiter, Saturn, and the others will have more pressure because they have more atoms in their atmosphere than Earth does. So that's Earth's atmosphere and its layers.